tech stories always end happily with a completely satisfied service customer. But this film is going to be different. It begins with a satisfied customer.
Now, let's see. Oil change, car wash, and charge it. Okay, that's set. Oh, hi, Al. Say, you'll be interested to hear that Mr. Jackson there was just telling me how happy he is with the air conditioning in his new car.
Well, since it'll be up to me to keep him satisfied, I better bone up on the new air conditioning control system.
Let's take time to review it now. I got the latest information on this new unit at the training center last week.
Good. I noticed that the refrigeration system hasn't changed much from last year, but I'd like to know more about the new air distribution system and how the controls work.
Okay, Al. To begin with, this new Plymouth and Dodge air conditioner has only 4 push buttons instead of 5. The water flow valve is vacuum actuated instead of being directly connected to the temperature control lever cable. The evaporator is located downstream from the blower for better cooling, and the blower itself is a highly efficient AXIAL-FLOW type. Those are a few of the improvements.
All that's important, I know, but what I'm interested in is how it operates.
I'm coming to that now, Al. Fresh air enters through the outside cowl vent and flows past the open fresh air door to the blower. For fast cool down, interior air is recirculated when the fresh air door is closed and the recirculating door is opened. In the housing, the air flows through the evaporator where it's cooled and dehumidified when the air conditioner is operating. Then it's reheated as necessary by the heater core before it's discharged into the car. Of course, the air flows the same for wintertime heating too, but the evaporator's not doing any cooling.
As I remember it, the 2 top doors control airflow to the spot coolers. The 2 bottom doors control airflow to the upper outlets in the instrument panel. And there's a heat door inside the housing, too. How do all these doors work, John?
It depends on which push button is selected. One vacuum actuator opens or closes the top doors, and another one opens or closes the bottom doors.
But even when the bottom doors are closed, some air passes them and is discharged from the upper outlets in the instrument panel.
Sure, Tech, that figures. Some defrosting air is always needed when the heater's operating, even if the driver has the heat button pushed in.
But on the other hand, the top doors, or spot cooler doors, shut off the airflow completely when they're closed. They open only when the cool button's pushed. Now, do you suppose we can get John to explain how the heat door is controlled?
That's next on the program, Tech. Notice that the heat door has no separate vacuum actuator. Instead, it's controlled by a linkage that's attached to the actuating levers for the other doors.
So the position of the heat door depends upon the position of both vacuum actuators, doesn't it?
That's right, Al. Here's how it works. When the doors for the spot coolers and the upper outlets are all closed, the linkage holds the heat door wide open. When the spot cooler doors are closed and the doors for the upper outlets are open, the heat door is only partly open. When the doors for the spot coolers and the upper outlets are all open, the heat door is completely closed.
That's good information. But tell me this. Just what happens when I push each of these buttons? Oh, sure, I know the push-button switch directs engine vacuum to the vacuum actuators, and I know it also energizes the blower motor and compressor clutch electrical circuits at the right time. But specifically, what does go on when each button is pushed?
Well, let's start with the heat button now. When it's pushed in, vacuum is directed to the rod side of all vacuum actuators. This closes the doors for the spot cooler and the upper outlets and opens the heat door completely. The fresh air door is also opened and the blower is turned on, bringing fresh air into the unit. Then it's warmed by the heater core and discharged mainly through the floor level outlets, although some does flow out of the upper outlets for defrosting too. When the defrost button's pushed in, the only change is that the vacuum is switched to the other side of the actuator for the upper outlets, opening the 2 upper outlet doors and partly closing the heat door. Then most of the warm air is discharged from the upper outlets.
Well, that covers the heating cycle, but what about air conditioning?
Here's the story on that. When the cool button's pushed in, the electrical circuit to the compressor clutch is energized, and vacuum directed to the actuators opens the upper outlet doors and the spot cooler doors. This closes the heat door completely, so that air-conditioned air is discharged from the spot coolers and upper outlets. If the driver wants more cool air around his feet, he can also open 2 floor-level outlet doors manually.
Hey there, Professor. Aren't you forgetting something?
Oh, you mean the blower switch. No, Tech, I plan to get to that now, although I'm sure Al knows quite a bit about it already.
I know, for example, that the blower switch has 4 positions, and that the first 2 positions give low and medium blower speeds with fresh air intake, while the 3rd and 4th positions give medium and maximum blower speeds with recirculated air.
Recirculated air isn't desirable for heater operation. It's apt to fog up windows, for one thing. So, in the 3rd and 4th switch positions, the blower won't operate with the heat or defrost button pushed in. These 2 positions work only when the cool button's selected.
But how does the blower switch control the fresh air door and the recirculating door to give these combinations, John?
See this little vacuum switch mounted on the blower switch? It's called the maximum cool switch. A rotating cam attached to the blower switch shaft controls the maximum cool switch to direct vacuum to the proper side of the fresh air door actuator. When the knob on the blower switch is in either the 1st or 2nd position, the maximum cool switch directs vacuum to the rod side of the fresh air door actuator. This opens the fresh air door and closes the recirculating door. When the knob is moved to the 3rd or 4th position, the maximum cool switch directs vacuum to the back of the actuator. This closes the fresh air door. The recirculating door is linked directly to the fresh air door so that it opens when the fresh air door closes and vice versa.
You're doing fine so far, John, but you've still got one more push button to consider.
Yeah, that's right. What happens when the off button's pushed in?
When the off button's pushed in, the push button switch directs vacuum to the rod side of the actuators for the spot cooler and upper outlets. This closes those doors and opens the heat door. Vacuum is also directed to the other side of the maximum cool switch. No matter what position the blower switch is in, the fresh air door will be closed when the off button's pushed. In the 1st or 2nd position, the maximum cool switch directs vacuum to the back of the fresh air door actuator. This closes the fresh air door and opens the recirculating door. However, if the blower switch is in the 3rd or 4th position, no vacuum reaches the fresh air door actuator through either hose. In this case, the fresh air door is held closed by an over-center spring.
Well, that takes care of the push button operation, but there's one other control we haven't gone into yet. The new vacuum actuated heat selector system.
Okay, Al. Let's trace this system down, starting at the temperature control lever. The lever is linked by a short cable to a pair of thermostatic valves. These valves sense the temperature of the air leaving the heater core and modulate the vacuum which controls the water flow valve.
Why is it necessary to have 2 thermostatic valves, John?
Because there are different heat requirements for heating and air conditioning. The left-hand stat is for the heating operation, and the right-hand stat governs reheating during air conditioning. Both stats are identical except for the contour of the cams. The contour and position of each cam determines the tension applied to the bimetal spring, and this governs the temperature at which the spring will open or close the valve. That's how the stats work. But, of course, there's more to this temperature control system than just the stats.
Sorry to interrupt you, John, but we're running out of grooves on this side of the record.
Now, let's see what else there is to this temperature control system.
Can you tell me how vacuum from the 2 stats is routed to the water flow valve?
Sure. The outlet from each stat is connected to the temperature selector switch. This switch determines which stat vacuum line will be connected to the water flow valve vacuum line. A lever on the spot cooler shaft controls temperature selector switch position. The water flow valve is held closed by spring pressure until the vacuum from the temperature selector switch becomes strong enough to open the valve. This allows hot water to circulate through the heater core.
Although both stats operate continually, the temperature selector switch allows only one stat to control the water flow valve at a time.
That sure fills me in on how this new air conditioner operates. While you were at the training center, did you pick up any good practical service tips I can use? For example, got anything new on the refrigeration system?
Refrigeration system service can be summed up quite simply. Just stick to the same basic procedures that were recommended for last year's models, and you won't go wrong.
Well then, what about the air conditioning controls? For example, how about diagnosis of the two stats?
In troubleshooting the air conditioning, keep this in mind. Erratic heat output, or no heat at all, may be caused by a faulty stat.
Before you test the stats, always check for pinched or leaking vacuum hoses, and be sure the temperature selector switch is okay.
Right, Tech. But to answer Al's question about testing the stats, connect a vacuum pump that'll deliver at least 20 inches of vacuum to the air conditioning vacuum source hose at the intake manifold. Then, turn the ignition switch to the accessory position. Turn the blower switch to the number 2 position and push the cool button. The blower should be kept running for the entire test. Place a thermometer in the upper outlet grill so you'll know when the temperature is stabilized. There should be less than 1 degree per minute change in air temperature when testing the stats. While you're waiting for the temperature to level out, remove the small diameter vacuum hose from the right side of each thermostat.
It's easier to get at the stats if you first remove the radio speaker grill and the speaker.
Here's a tip. To disconnect the vacuum hose, I found it's easier if I catch a fingernail or some thin-bladed tool over the end of the hose and work the hose off with a twisting motion.
Good suggestion, Al. Now, to test the heater stat, the one on the left, remove the large diameter vacuum inlet or source hose from the other stat and plug it. Then connect the vacuum test gauge to the right or outlet side of the heater stat with a test hose.
It's very important that you use a test hose with a 3/16 of an inch inside diameter, exactly 48 inches long. Now, the specifications for this test have been calibrated for this specific size hose.
That's right. Just any old hose won't do. Next, put the temperature selector lever in the off position and move it slowly toward the center of its slot. Stop when the line on the cam arm is aligned with the line on the stat body. Don't overshoot, or you'll have to move the lever back to the off position and start over. When the temperature is stabilized, read the thermometer and vacuum gauge. For any given temperature, the vacuum should be within the specified limits.
Now, these limits are given in the reference book for this session. After you've checked the calibration of the stat, make sure the check valve in the thermostat is working.
To do this, disconnect the vacuum source hose. If the vacuum gauge drops less than 1 inch in 1 minute, the check valve's okay.
And I suppose that you check the air conditioning thermostat the same way, by connecting the vacuum source hose to the stat on the right, disconnecting the vacuum source hose from the heater stat and plugging it, and attaching the vacuum gauge to the outlet side of the air conditioning stat.
That's right, Al. And if either stat doesn't check out okay, replace the assembly. You can't adjust or replace the stat separately. Now, here's some more important service tips. When you remove or install the stats, roll the entire assembly in or out of the housing from the bottom to avoid damaging the cam followers. And never attempt to tighten or loosen the 4 screws that hold the individual stats in place. You could upset their calibration.
I'll remember that, John. Say, while we're on the subject of the vacuum circuit to the water flow valve, how about telling me how to test the temperature selector switch?
Glad to. Matter of fact, you should make sure that switch is okay before you test the stats. To test the selector switch, attach the test gauge to the vacuum pump. Close off the end of the test hose so there's no vacuum leakage, and adjust the gauge bleed valve to get a reading of exactly 8 inches on the vacuum gauge. Disconnect the vacuum hose from the water flow valve and plug it. Use a T-fitting to connect the 2 small stat hoses to vacuum gauge test hose. If there are no leaks, the vacuum will pump down to 8 inches. Do not readjust the gauge bleed valve. Push and release the plunger on the temperature selector switch a few times and watch the vacuum gauge. A drop of more than 1/2 inch indicates excessive leakage. If inspection of the hoses doesn't uncover the leak, replace the switch.
Sometimes a vacuum leak in the temperature selector switch can cause a whistle in the thermostat. It's caused by excessive airflow through the stat. So if you encounter this condition, don't blame the stat before you check out the selector switch.
Thanks, Tech. I'll keep that in mind. Now, do either of you guys have any tips on adjusting the fresh air door?
I think we can help you there, Al. To see if an adjustment is needed, remove the sound deflector and the flexible duct. Then disconnect the blower ground wire and tape the end to ensure that the blower won't operate while you're working in that area. Start the engine. Push the cool button in and turn the blower switch to the number 1 or 2 position. The fresh air door should open fully against its stop. The recirculating door should fully close, compressing the sponge seal to prevent air leakage. Then, turn the blower switch to the number 3 or 4 position. The recirculating door should open and the fresh air door should close fully, forming a tight seal so there's no leakage past the door. That's how the system should work. But if you find a need for adjustment, stop the engine to remove all vacuum from the system. Then disconnect the link at the ball and socket joint on the fresh air door. Hold the fresh air door wide open against its stop and hold the recirculating door tightly closed, compressing the sponge seal. Hold the doors in this position and adjust the length of the link to line up the socket with the ball. Then snap them together.
Be very careful not to bend the ball bracket when you're making this adjustment.
Okay, Tech. Is that all there is to the adjustment?
No, there's one more point we haven't covered yet. You remember it, John?
Sure do, Tech. Start the engine and operate the controls to see if both doors open and close okay when vacuum's applied to the system. If they don't, you might have to remove the glove box and adjust the travel adjustment screw until the travel of the doors and the vacuum actuator agree.
That's it, John. And always remember to check the system with the blower switch in both the fresh air and recirculating positions after you've made any adjustments. By the way, you can use the vacuum pump for your source of vacuum for this test instead of running the engine, if you want to.
While we're discussing vacuum actuators, here's a tip that's handy. Sometimes an actuator rod seal will pull out or leak, making the actuator ineffective. Pushing the seal back in place and lubricating the rod with a silicone grease usually corrects this problem. And I found that the vacuum hose with a red stripe is always connected to the rod side of every actuator, while the one with a white stripe goes to the other side.
Those are good tips, Al. And here's another. You'll find everything we've talked about, plus the control cable adjustment and water flow valve test, covered in detail in the reference book.
I won't miss that, Tech. You know, in this business, I've found out it's a big mistake to think there's nothing more you can learn.
That's very true, John. And every service technician should take advantage of all the service training available to them today, such as the Chrysler training centers and the monthly Master Tech sessions.
And I'd like to add, this desire to learn really pays off in many ways. Better service to your customers, building a successful dealership, maintaining the reputation of Chrysler Corporation products, and last but not least, it pays off in the satisfaction that comes with doing a good job.
Thank you.